Hi, Maddie. I really hope that this will be a good opportunity for us to get through some of the points that you talked about. There were 3 things that you talked about. The first of these was simplifying square roots, which I think makes, sense to do before we do the next one. The second is the Pythagorean theorem, which really relates to simplifying square roots. And the third is properties of real numbers. So I think what we'll do is we'll look at each of these in order that I just gave you, and we'll talk about each and see if it'll be helpful. All right. The other thing I want to mention or say or apologize for is that my handwriting is terrible on an iPad, but hopefully it's clear enough. I'll try to write large and just do one example at a time. So the first thing I like to tell students to do when they start thinking about simplifying square roots is knowing what your perfect squares are. And we talked about all of these today, and I know you have them down to about, I think we got up to like 13. Oh, did you see how I missed 12 squared? That's 144. That should be in there. I'll fix that in a moment. Anyway, so we've got all the perfect squares up to like 16 squared, which is 256. And so these are things that you need to keep in mind. So if you can hold on to these, we can start working on simplifying some square roots. Okay, we've got that corrected. So let's look. If we took if we were taking the square root of 121, you would easily tell me that the answer was 11, because you know from memorizing our list that 11 squared is 121. However, that looks terrible. Let's see. Forgive me, Maddie. You see I'm trying to make this look all pretty. Okay, so we see that the square root of 121 is 11. However, things get difficult when we're doing the square root of numbers that are not perfect squares. Let's say like the number 50. So if we do the square root of 50, and we talked about this, we know that the answer should be somewhere really close to 701, 7.01. And that's if we use a calculator. Your teacher doesn't want you to do that. She wants you to give, or he wants you to give an exact answer. So here's what you're going to do. You're going to take 50 and factor it. You can factor 50 in a lot of ways. You could say 5 times 10, which is totally legit. You could factor 50 as 25 times 2, which is cool too. You could factor 50 as 1 times 50. There's a lot of ways to do it, but you want to do it in the most helpful way. The one that is most helpful at this time is going to be the factor that includes a perfect square. So this is the one that we're looking for. So to give us some more space, I put the 50 here, the square root of 50, and I'm going to write it as the square root of 25 times 2. Now to simplify this, I know that the square root of 25 times 2 can be written as the square root of 25 times the square root of 2. And that gives me, well, square root of 25 you know is 5, and the square root of 2 we can't do, so the answer is 5 root 2. If you were to put this in a calculator, you'd get approximately 7.0. You put 5 times square root of 2, you get 7.0 or something like that. But what I want you to keep in mind is that the way that we factored this out keeps us from getting stuck. Let me go back to that last example. Had we done the square root of 5 times 10, we would have been stuck. We would not have been able to simplify anything. So this was not the way to go. So the key to these types of problems when you're simplifying radicals is to take the square root, of factors that are perfect squares. And that's why we keep this list over here. All right. Maddie, here are a few examples that I'd like you to try alone. Feel free to pause me and try them, and then you can check out the explanation as we go along. So here are the answers to the problem. So how I'd handle this one, square root of 18, I'm going to look for the perfect square, the largest perfect square that divides evenly into 18. And if you look in our list over here, we see that that answer is 9. So I get the square root of 9 times 2. I break up my radical. I get the square root of 9 times the square root of 2. And then my answer is going to be 3, which is the square root of 9, and then 2. So 3 root 2. The answer to this guy is going to be the square root of 25 times 3. Again, I'm looking for the largest perfect square that divides evenly into the value. So the square root of 25 times 3 is what we get. Square root of 25, I'm going to just, for space sake, I'm just going to write 5 here. That's the square root of 25. And then I'm going to write radical 3. if we take the square root of 24, this is kind of an interesting problem, and I'm going to show you a mistake that people make. Well, not really a mistake, just a different path that people go on. So some people will look at 24 and say, okay, well, the highest, well, actually, this isn't a mistake. Well, the highest possible, this isn't a mistake. This is the one I was talking about. I'll tell you about another one later. If I take the square root of 24, I'm going to look for the greatest square that divides evenly into it, and 1 goes into all of them. That's no help. 4 goes into 24. Let's see, 9, no. 16, 25, too high. So we're going to stop at 4. So if I do the square root of 4 times 6, I see that I can get the square root of 4 to be 2. And the square root of 6 stays as it is. So 2 root 6 is my answer. Next one, I'm going to do the same thing. This one is going to be 4 times 2, because 4 is the largest perfect square that divides evenly into 8. So the square root of 4 is 2, and my answer is 2 root 2. Finally, with 72, this is where I'll show you a common mistake that people make. So if you look at 72, you might say, okay, well, 4 goes into 72, I think, right? So you can say, well, 4 times what is 72? 4 times, 18. And you can take the square root of that and get 2 root 18. However, and that's me taking the square root of 4, getting the 2, and then leaving the 18 underneath the radical. What you'll see, though, is before we actually handled the square root of 18, so we're not done. How do you keep yourself from a position where you have to continue to work through that? I'll show you in just a moment. Okay, sweetie, so here's our example again, the square root of 72. And the first time we did it, we took 4 times 18, and we realized we ended up with 2 root 18, but 18's not done. So I can, because there's still a perfect square that goes into 18, which we know to be 9. So I get 2 times the square root of 9 times 2, which then further becomes 2 times the square root of, let me take that square root off. 2 times square root of 9 is 3, so 2 times 3 times the square root of 2. 2 times 3 is 6, so I get 6 root 2. Pause me anytime this is too much. At this point, this is the complete answer. I've simplified it correctly. However, could I have done that quicker is the question. And what we need to do is really have a good mind about what our perfect squares are. So here's what I'm thinking about, right? I'm thinking about my perfect squares. 1, 4. What's the next one? Go. 9, 16, 25, 36, 49. And what I'm thinking is, which one of these goes evenly into 72? And the answer is 36. You want to pick the largest perfect square. Yes, 4 goes in there. 16 go. 16 may even go. I don't know. I can't think of it right now. I don't think 16 goes. No. Anyway, so 36 is the largest perfect square that divides evenly into it. And watch how it saves us time. By taking the time to find the largest perfect square, I get square root of 36 times 2, which gives me 6 root 2. I got to the answer really fast, right? Same answer. Here's the take-home point. You can get to the answer even if you have to take a longer time, but look at the steps. More steps means more opportunity for mistakes. So it's better if you can find the largest perfect square. If you don't, feel free just to keep whittling it down. Okay, that wasn't the most gracious transition, but my kids were getting loud. So hey, Maddie, sorry for the cut again, but I need to actually make another video for you because I got to cut it in half. YouTube doesn't allow me to send you a video that's over 15 minutes long. So just check out the other clip.